Hey everybody, I'm Corey. Thanks for joining me. Today we are going to do some Advent of Code puzzles. The Advent of Code puzzles are some daily puzzles that we get from the 1st to the 25th of December. And today we are on day number 9. So let's jump right into it. Day number 9, Mirage Maintenance. You ride the camel through the sandstorm and stop where the ghost's map told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one is made of metal. That must be where the parts to fix the sand machine come from. There's even a hang glider partially buried in the sand here. Once the sun rises and it heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of Desert Island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Your puzzle input. Each line in the report contains the history of a single value. For example, 0, 3, 6, 9, 12, 15, 1, 3, 6, 10, 15, 21. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the... To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Once all the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. Hey, Fallen Angel 623, we are doing an Advent of Code puzzle. This is day 9. So these are some daily coding puzzles in December. And so we are just reading through what the puzzle is and what our input looks like. And we're going to go from there. We're going to probably code this up in Rust. That's what we've been doing here. But first I need to understand what's going on because I'm getting a little lost in these prediction stuff. So let's walk through their example. In the above dataset, the first history is 0, 3, 6, 9, 12, 15. Because the values increase by 3 each step, the first sequence of differences that you generate will be 3, 3, 3, 3, 3. Note that this sequence has one fewer value than the input sequence because at each step it considers 2 numbers from the input. Yeah, so the difference between these is 3, then 3, so that's all the 3s. Since these values aren't all 0, repeat the process. The values differ by 0 at each step, so the next sequence is 0, 0, 0. This means you have enough information to extrapolate the history. Visually, these sequences can be arranged like this. To extrapolate, start by adding a new 0 to the end of your list of zeros, because the zeros represent differences between the two values above them. So this means that there is now a placeholder in every sequence above it. Okay, yep. You can then start filling in placeholders from the bottom up. A needs to be the result of increasing 3, the value of its left, by 0, the value below it. This means A must be 3. Okay. Finally, you can fill in B, which needs to be the result of increasing 15, the value to its left, by 3, the value below it, and getting 18. So the final value of the first history is 18. Finding all 0 differences for the second history item requires an additional sequence. So you go, because it's 2, 3, 4, 5, 6, and then these are all 1, 1, 1, 1, and then you get zeros. Then, following the same process as before, work out the next value in each sequence from the bottom up. So that's a 1, 7, 28, and that makes sense. So the next value in the second history is 28. The third history requires even more sequences, but its next value can be found the same way. We go down, those are the differences, and then you get 2, 4, 6, 2, 2, 2, 0, 0, 0. And you work it back up and you get 68. If you find the next value for each history in this example and add them together, you get 114. Okay, so parsing is going to be pretty easy on this one. It's just a list of numbers separated by white space. And then so for each history, though, we need to calculate the next value by extrapolating a line below it. So this is going to be an interesting one. I think we can get started and see how it goes. I think we're going to do something recursive-ish probably. But let's just get started with parsing our input. So we need to make a new cargo binary for this. Oh, cargo new binary. It's day 9, and this day is Mirage Maintenance. Name Mirage Maintenance. Should have filled up my water before stream. Oops. So I now have to add it to the top level cargo.toml for our workspace and put it in quotes. Mirage Maintenance. Cool. We can go into that directory now. And cargo run gets us started. Okay, so let's copy in our sample input. New file, sample input. Throw it in there. Let sample input. Let sample part 1 answer. Debug sample part 1 answer. Perfect. Function part 1 takes an input. Oops, input string, except it's not that at all. Oh, that's another puzzle. That's fun. That was camel cards. Day 7. You can check out that video in my previous playlist. To do just for the moment, because I want to figure out if I want structs for any of these. So each line is a history. And we might just work with vex of numbers, honestly. So we might, this one might be pretty easy. We might just say that, like, let histories equals the input dot lines. And then for each line, we do line dot split on white space. Sure, split on ASCII white space, even better. Map those to parse to a usize. Collect all of the numbers to a vector, and then collect all the histories to a vector. Perfect. And actually, let's make a struct called history that contains a vec of usize. So once we get the vector of usizes, we'll do a map and make our histories. So now histories is a vec of history structs. Okay, so now we have our history structs, and what we want to do is we want to impl on history. We don't need any, oh, didn't want to debug that either. Uh-oh, hopefully this doesn't open up all kinds of debugging stuff it has before. I think we're good though. We want a function called next item, I think. And so what we need to do is we need to predict the next item, and to predict the next item, we need the next difference. So then we need a function that's the next difference of a array of usize. Yep. So to find the next difference, we need to find the differences. So let differences equal, oh yeah, is Windows in the, oh, that's just, it doesn't like that I don't return anything. Windows is in the standard library? Perfect. Yeah, okay, awesome. So for these, we do minus the other. Ooh, but I want like absolute value minusing. So and can I like pattern match these to like A comma B? And then A minus B, except I don't want A minus B. I want like A absolute diff B. Yeah, perfect. Wanted a reference? Oh, found a reference. That's fine. Cool, because now we have our differences. So then if differences dot all, if they're all equal to 0, then we are done. That's our base case here. Once all of the differences are 0, the next number is just a 0. Actually, so this is really just next number. It's really just, we're just doing next item, but on a slice. That works for me. We gotta make this an iter. Oops. Dot. Can't compare. Oops. That's a whoa. Reference there. That makes this a actual U size. We compare it with 0. Oops. Oh wait, so the next number here isn't, if the differences are all 0, the next number is the same as the last number. Array.last. Oh yeah, array.last. I like that way better. Yeah, it's the same as the yeah, because once they're all 0, then it's the same as the last one, because you get one where they're all the same. Yep. Mismatch type, expected nothing, found U size. Why does it expect nothing? Is it because of the to do? Mismatch type, expected U size, found reference to U size. Oh, okay, of course. Nice. Okay. So if the differences are 0, but if not, then we want to say let next difference equals next number of the differences. Oh, so I guess I also can just grab last here, let last equal, and then this can be last. Next difference is at last plus next difference. Mismatched type, expected nothing, found U size. Oh, because I wanted to return this here. That's what I was missing. Yeah, return last. If you need to keep going, you find the next difference by calculating the next number of our differences, and we just recurse down. I think that'll work. And then next item in our history, this is actually really easy. I might not even really have needed this method because it's just next number of self.0. That means this needs to take a reference to self, which makes sense. We can't operate on self if we don't take a reference of self to begin with. Expected U size found in nothing for part 1 answer. That's fair. What do we do in part 1? We just map to our histories and collect. So then let's do histories dot into iter dot map next item sum. Perfect. Pattern found. All of these are not covered. Yeah, that's kind of fair. I definitely didn't. This isn't exhaustive. That's okay. That would have been cool if it worked though. So this is the window. Let a equals, let's just, I don't need this. Let's do window at 0 and window at 1. There we go. 114. 114. Perfect. Get my puzzle input. Oof, big numbers. Oh, and there are some negatives, so I might need to change this up to be able to deal with negatives, but that's okay. Sample input, yeah, let's make a my input. Okay. Let my input, let my part 1 answer, debug my part 1 answer. Except let's make all of the numbers that we're talking about So substitute everywhere U size for I64 globally. So let's handle negative numbers and all the way up to I64s. Expected found reference. Oh, so where are the U64s? Oh, absolute difference gives you U64s. Dot differences dot map. So here we want to map it as an I64. Yeah. Big number for my answer. Oh, not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. There are also some general tips on the about page. Okay. Okay, so I still was getting that right. Would have been really cool if that just worked. And I don't think it's about changing it to an I. It's just that some of these, oh, I was doing absolute values when I maybe shouldn't have, because these are getting lower occasionally. And so I wonder if I shouldn't be doing, because in my original example, they were growing, right? So I should do B minus A all the time, maybe? Maybe that's what I should do. The second one minus the first one, and we just happen to be doing positive numbers the first time. These, now it always stays in I64, so we don't need the conversion. Yeah, let's try that. There we go. Okay, awesome. Day 9, part 1. Cool. Let's go to part 2. Part 2. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of zeros is entirely zero. Then, rather than adding a 0 to the end and filling in the next value for each previous section, you should add a 0 at the beginning of your sequence of zeros. Then fill in the first value for each previous sequence. In particular, here's what the third example looks like when extrapolating back in time. You do basically the same thing, but you just do it backwards. Adding the new values on the left side of each sequence from the bottom up reveals the new leftmost history item 5. Doing this for the remaining example data above results in previous values of -3 and then 0. Adding all of these together produces 2. Analyzing your Oasis report again, this time extrapolating the previous value for each history. What is the sum of these extrapolated values? Oh, okay, so let's just do it in the other direction. Okay. So we can do that. I think that should be pretty easy. So we can just take our part 1 and copy it and make a part 2. Oh man, I can't click on the right thing there. Part 2. And then all we need to do here is make this previous item. And we'll have to define the previous item. But that's about it. Let's get a let sample part 2 answer, debug sample part 2 answer. And then let's do previous item. That is a great trick, Copilot. I don't think I was going to think of that trick. The answer they got was 2, though. Oh, adding all 3 values together produces 2. Wow, that was a great trick, Copilot. The answer was just to reverse it. Because it's the exact same thing, and we were just going to do it to the left. So I was going to just like reverse all of these things and do it all, like just duplicate it in the opposite order. But the easy answer is just to reverse the list and then do exactly the same thing that I was doing. So thank you for that, Copilot. Love that answer. Sample part, oh, I already did the sample. Let my part 2 answer. Debug my part 2 answer. Cargo run. 1072. That's actually pretty small. There we go. That's the right answer. You're 1 gold star closer to restoring snow operations. So that was pretty easy. I like that, especially when we did the reversing trick. It wasn't going to be too hard to write this in the opposite direction, but it's much nicer to not need to do that. Yeah, because I would have had to flip these, would have flipped this to first, and then maybe subtracted the difference here. But it's nice to be able to not do any of that. I like it a lot. Day 9, part 2. Let's push that up. And there we go. I like that. That was a nice, easy, and quick one. That might have been the quickest one for us so far. And so with that, I think I'm going to get out of here. And everyone enjoy your evening. And I will see everyone tomorrow for day 10 of Advent of Code. See everyone online in the meantime. Thanks, team. Bye.